Hi there, Year 9. In this video, we're going to look at acid rain. Now, I want to start off by getting you to think about what the pH of rainwater would be. Now, you should remember from a previous lesson that pH relates to a scale of acidity, where the lower number means it's more acidic and the higher number means it's more basic or alkaline. So think about what the pH of rainwater might be. Now, it might surprise you to find out that rainwater actually is a little bit acidic. At least naturally, rainwater is a bit acidic. And the reason for this is because of the carbon dioxide in the atmosphere. Now, water is really good at absorbing carbon dioxide. And that's one of the problems with climate change that could potentially affect our oceans, where that excess carbon dioxide is being absorbed by the water in the ocean, which is going to lead to an increasing level of acidity of our oceans. Now, the water and carbon dioxide react and they form an acid called carbonic acid. Now, you might remember carbonic acid from that list of acids that you need to know, but it's this reaction that leads to acid rain forming, or rather the rainwater pH being a little bit more acidic. Now, when it comes to acid rain, we're talking more about the pollution that's in the atmosphere that is causing that rainwater to become even more acidic. Now, it usually occurs through the burning of fossil fuels, so carbon dioxide being one of them that gets released, sulfur dioxide and nitrogen oxide. Now, if you look at those words, carbon, sulfur and nitrogen, that might clue you into what sort of acids are going to be formed when water reacts with those particular oxides. Now, again, remembering our list of common acids, what do you think carbon dioxide, sulfur dioxide and nitrogen oxide will turn into in terms of acids when they mix with water? Well, again, go back to that list of common acids that we need to know. So sulfur dioxide makes sulfuric acid, nitrogen oxide makes nitric acid, and carbon dioxide, which we spoke about before, makes carbonic acid. Now, acid rain is rainwater that has dissolved those acids. It's absorbed those oxides in the air, those gases, and turned them into acids. So as they return to Earth, they fall as rainwater that has a higher level of acidity than normal rainwater. So the pH of acid rain is generally much lower than normal rain. So normal rain has a pH of about 6, whereas acid rain can be as low as a pH of 3. Now, if you can imagine in really extreme circumstances, if we've got a really acidic rainfall occurring, it might have some really drastic effects, particularly on the environment. And here's a couple of pictures of the impacts of acid rain. On the left-hand side, we've got some trees here that have had their foliage stripped back and perhaps are not going to survive much longer because of the acidic changes in the soil and the way they get their water. And here we have a lake where there's been a large fish kill as a result of a large amount of acidity or a big acidic change in the water that those fish live in. But it's not just the living environment that acid rain can impact on. It can also impact on the physical environment that we live in. And acid rain is well known for the way that it dissolves marble or reacts with marble and causes these really characteristic dissolving patterns. So marble is what these statues are made out of, and you can see these cracks here, and particularly on this picture here where there's lots of erosion happening on that particular statue. And so what happens is as the acid rains or the acidic rain falls on these statues, it starts to react with the marble and erodes that marble or wears it away at a much higher rate. You wouldn't normally see that pattern with normal rain. It's very much a function of acid rain. And these are the sort of things you would see in areas where there's high industrialization and there's a lot of that pollution in the air normally anyway. Now, when it comes to acids and marble, we need to understand, or we need to think about a compound called calcium carbonate. And I want to talk to you about middens as a way of explaining calcium carbonate. Now, middens, you may or may not know, are mounds of shells from shellfish. And they're mounds that are put there deliberately, or were put there deliberately, by Aboriginal and First Nations people. And it served lots of different purposes. It could be a meeting place for some groups, some families, but also it sent a signal to groups that would come through what was the most recent animal that was eaten, or the most recent shellfish that was eaten, as a guide to leave that particular shellfish alone so that the next group doesn't overfish that particular species. Now, when Australia was colonised during the First Fleet, what happened was the Europeans, the English, realised that these middens were shells and calcium carbonate, and that they could use that, crush it up and mix it together and make quite a strong mortar, and used it to help with their building in holding these sandstones together. These are some of the old buildings in Sydney. And so if you walk down, particularly through the rocks, you'll see in their mortar of the sandstone there, sometimes you'll see bits of shell sticking out there because of the way that these middens have been crushed and used and repurposed for making that binding agent that holds the stones together. Now, the trouble with that, as you might already be starting to piece together, is if Australia ever got to the point where we had common acid rain falling, then that could certainly interact or react with that mortar and make those buildings' structure not as strong as what they currently are, and could potentially cause some real problems. Now, last week I asked you to set up a prac where you're going to look at acid and how it reacts with carbonate. The prac that we were going to do was vinegar and chalk. So hopefully you've had a chance to set that up and let it go over the weekend, and you can complete that prac today as well. If you haven't done that, that's fine. We've got another activity for you to go on with.